Hi, everybody. It's Miss McClellan here to go over our practice checkpoint 6.1 with you. Okay, so number one has me solving for missing side lengths on special right triangles. Number two has me writing down sine, tan, and cosine of our special angles. Number three has us using the Pythagorean identity, not to be confused with the Pythagorean theorem. And number four has us rationalizing denominators. Let's get started. Okay, number one. This is a 30, 60, 90 triangle, and I am being asked to solve the length of x. So to make this easier on myself, I like to always draw my standard triangle, my standard 30, 60, 90 triangle with hypotenuse 2, short leg 1, and long leg √3. And then I can sort of just use a scale factor because I know that 1 times 3 is 3. So I'm multiplying this triangle by 3 to get that triangle. That means that since I'm solving for the hypotenuse, I just need to do 2 times 3 equals that hypotenuse x, and x is going to be the value 6. Okay, here I go again. This one's just a little bit harder. I'm still going to try to scale from my original special right triangle to this one. I have a 30, 60, 90, and this time I'm trying to solve for the length of y. Now, the reason this one's harder is because it's not immediately obvious what I need to multiply by √3 to get 8, but I can solve for that. √3 times, let's say a equals 8. To get a, I divide both sides by √3, and I get a is 8 over √3. That means whatever I multiply by, whenever I multiply one of these sides by 8 divided by √3, I get a bigger triangle. So let's multiply 1, because 1 is the side that corresponds to y, by 8 over √3. Well, that equals just 8 over √3, which is the length of y. I'd like to rationalize my denominator, which gets me 8 √3 over 9 as my length for y. There it is. Now, if you had written y equals 8 √3, it would have the correct value. Oh, I'm sorry, 8 √3 over 3. That was a mistake on my part. √3 times √3 is not 9, it's 3. Ha ha ha. 8 √3 over 3. And I'll even rewrite the whole thing to make it extra clear. Y equals 8 √3 over 3. If you wanted to leave your final answer as 8 divided by √3, that would be acceptable for number one. Okay, we continue. What is the value of n? This time I have a different special right triangle. This is a 45, 45, 90. Which follows the pattern 1, 1, √2. So I'm asked to solve for the value of n. Well, there's a couple ways I can do this. First of all, I know it's going to be 3 because a 45, 45, 90 is isosceles. So this is 45 degrees and this is 45 degrees, meaning these two lengths have to be the same. I actually don't have to do a lot of special work for this one. Now let's do it for m. So now I'm solving for m. Same triangle, solving for m. I know I multiply my original triangle by 3. So now I have to multiply my original triangle by 3 again to get this missing side. And that is √2 times 3, which we write as 3 √2, so that we don't make any mistakes putting 3 under the radical where it doesn't belong. Okay, next. These might intimidate, and you might be tempted to memorize them, but I strongly suggest that you do not memorize these. If you know that sine is opposite over hypotenuse, so And you know that cosine is adjacent over hypotenuse, and you know that tangent is opposite over adjacent. You can do all of these just by referencing your special right triangles. Special right triangles. So I suggest that you draw these triangles on your quiz. Then you can use them. So let's do the 45-degree angles first. That uses this triangle. Sine of 45. Well, that's opposite over hypotenuse. 1 over the square root of 2. Cosine of 45. Well, that's adjacent over hypotenuse. 1 over the square root of 2. And tan of 45. Well, that's opposite over adjacent. You might actually just know that this is equal to 1, which would be acceptable. I'm going to rationalize these denominators. Final answer. I multiply top and bottom by root 2. Okay, now for the 30, 60, 90 triangle. For this, I'm going to use this up here. I'll do 60 degrees first. So sine of 60 is root 3 over 2, opposite over hypotenuse. Cosine of 60 is 1 over 2, adjacent over hypotenuse. Tan of 60 is root 3 over 1, or just root 3. That's opposite over adjacent. Now for 30 degrees, I have a different reference angle that changes what is opposite, adjacent, and adjacent. Sine of 30 degrees, that's opposite over hypotenuse, 1 over 2. Cosine of 30 degrees, that's root 3 over 2. Tan of 30 degrees, that's 1 over root 3. But I want to rationalize my denominator. So this is root 3 over 3. I'm going to circle my final answers. And that's it. Okay, next problem. What is the value of x in the equation below? Let me focus. Well, I know my Pythagorean identity, which says that sine of x squared plus cosine of x squared equals 1. Since this is sine of 20 degrees squared plus cosine of x squared equals 1, I know that this x has to be the same measure as the angle in my sine, because otherwise I wouldn't have sine squared plus cosine squared equals 1. So this is just going to be 20 degrees. I know because sine squared x plus cosine squared x equals 1. Meaning these two measures have to have the same value. If when I square the sine and cosine and add them together, I get 1. Okay, next problem. This one's a little bit harder. Sine of x, what is sine of x if cosine of x is 9 over 11? I'm going to draw a triangle. Here's x, and cosine is adjacent over hypotenuse. So what I need to know is what is opposite over hypotenuse, meaning I need to solve for this missing side length. And in order to do that, I need my Pythagorean theorem. So the Pythagorean theorem says that the leg squared, I'll call this, what should I call this? How about A? Plus the other leg squared equals the hypotenuse squared for right triangles. I'm going to subtract 9 squared from both sides. I have a squared equals 11 squared minus 9 squared. Take the square root of both sides, and I have a equals the square root of 11 squared minus 9 squared. Now that I know what a is, I can say what sine of x is. Since we don't have calculators, this is fine for a. So sine of x is going to be 11 squared minus 9 squared over 11. I don't think that's very clear to look at. I'll write it bigger. Sine of x equals the square root of 11 squared minus 9 squared over 11. And I know because I can construct a triangle, a right triangle, to find missing lengths, and then write sine. You know, on your test, I'll probably take out the I know because for this problem, because I can tell how you've done this by inspection of your work. Okay. 4a, rationalize your denominator. 1 over the square root of 12. I don't want the radical in the denominator, so I multiply top and bottom by that radical. And I get root 12 divided by 12. Final answer. Okay, this one, rationalize the denominator. I multiply top and bottom by that radical root 2. And I get 6 root 2 over 5 times 2, which is 6 root 2 over 10. And if you leave it like this, you'll still get full credit, but I'm going to take it a step further and simplify my fraction. This is equal to 3 root 2 over 5. Thanks so much for following along. I hope you have a beautiful day, and I hope this is helpful for you. Okay, bye.